Hello. Today we're going to be talking about a difference of proportions in samples. So yesterday you counted your sample of M&Ms and Skittles, or at least one person did, found the proportion of orange candies in each, and then calculated the difference. I put your data plus a few extra data points on this dot plot here. Copy it down, and then I'd like for you to try question 3 and 4 before unpausing this video and watching my notes. Okay, you should be able to do them. They should take you maybe a minute. It's just estimating. Try 3 and 4 and then come back. All right, now that you're back, let's just start going over a few things on the first page before we move to the second. In question 1, so remember that because in part 1, my proportion here comes from a sample, I would label it as p hat. But now we have 2 samples, so we really want to make sure we're keeping things clear between what's the first sample and what's the second sample. So we add a subscript now. This is p hat 1. And then the Skittles will be p hat 2. So then when we're showing that we calculated the difference between M&Ms minus Skittles, we do p hat 1 minus p hat 2. And those are the symbols that we use now that we're doing a difference in proportions. So we have this dot plot here, which I would label as a sampling distribution of p hat 1 minus p hat 2. Okay, so each individual dot, right, that's a different group's p hat 1 minus p hat 2. Okay, so then that's kind of how you would have described in question 3 what each dot represents. So what I said was one random sample of M&Ms and another random sample of Skittles, and the difference of proportions of orange candies in them. You could say something similar to this. What I really just want you to understand is that a dot in this dot plot is one sample, and this difference in proportions from that sample. Technically 2 samples, but for one group. All right, now for the dot plot, now we're just making some predictions here because we're not really sure what exactly to do. So we predicted that the shape would be approximately normal, at least I did. I don't know what you did. I predicted the mean would be about 0.04 and the standard deviation would be about 0.07. And I just said positive 0.04 since there was a negative option. We shouldn't have that many negative data points. All right, so now on the second page, now we have some new information, and that is that Google reveals that 25% of M&Ms are orange and 20% of Skittles are orange. And so I'm going to label each of these values. What that tells me, 25% of M&Ms are orange, that's telling me P, right? Not P hat, it's not the sample, it is the true population proportion of orange candies. So P1 equals 0.25. And then for Skittles, that was P2. So P2 equals 0.2. All right, so now we are going to continue on using the ideas from the previous lesson. Describe the sampling distribution of p hat for M&Ms and the sampling distribution of p hat for Skittles for samples of size 50. So this goes back to what we did yesterday in class, right? As if we just had the Reese's Pieces. How did you find the shape, the mean, and the standard deviation? So just to remind you, what we did yesterday for shape, it was large counts. For mean, the formula we found was that mu sub p hat equals p. And for standard deviation, sigma sub p hat equals the square root of p times 1 minus p over n. Pause the video and see if you can fill this in for both M&Ms and Skittles. Make sure that you've paused the video, and then you can go fast speed through me just writing these out, because I don't know how to pause a video on my iPad so that I can write stuff and it not be recording. You know what I could probably do is just stop the video and then edit the two together. But I'm excited to go out in the snow. Did you guys get any snow today? I hope so. Do you like the snow? I don't know. Tell me on Monday. So if you have come back from doing it yourself, maybe you were able to calculate all these, but did you use the appropriate symbols as you calculated them? So just make sure that you have the symbols right with the correct subscripts. And notice it's like we have a double subscript, because not only are we saying that it's mu sub p hat, but it's mu sub p hat 1, mu sub p hat 2. And here are the values that you should have gotten. Now, for question 6, describe the sampling distribution of the difference between the proportions of orange M&Ms and Skittles, X minus Y. Now, you're all going to have to be your own keeper's keeper, but this would be like for for combining random variables. Do you remember how we combined random variables? If not, check your keepers and answer these 3 questions. All right, so if you've come back from checking your keepers, you would know that the shape should stay approximately normal. Because both of them are individually normal, we can say that together they will also be approximately normal. The mean of the difference is just going to be the difference of the original means. We can actually just go ahead and subtract them. Now, the standard deviation, if you tried to subtract it, and that's not quite what we can do, because remember our saying, you cannot simply subtract standard deviations. Instead, what we have to do is we add the variances. So variance is standard deviation squared. And then we take the square root to get our final standard deviation. So now what we've just gone through, you're not going to necessarily have to calculate everything separately and then think about combining random variables. This is what we call a 2-sample problem, as opposed to before what we did when you did one of them individually was a 1-sample. So when it comes to 2-sample, here's what we do. For large counts, you just have to test it for both. So basically, I guess it is what you did above. N1, P1 greater than or equal to 10, N1, 1 minus P1 greater than or equal to 10, N2, P2 greater than or equal to 10, and N2, 1 minus P2 is greater than or equal to 10. You have to test all 4, and you have to show it on your tests and quizzes and the AP exam. You have to show plugging into this formula and proving large counts. You have to. Okay. Now for the mean, the formula for mu sub p hat 1 minus p hat 2 is just p1 minus p2. And then for standard deviation of p hat 1 minus p hat 2, the formula is, and now this is going to look a little bit crazy. Might not even have enough room here, but let me write it and then I'll explain it. It's P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. 2. And you might be thinking, well, where, I thought it was standard deviation squared plus standard deviation squared. This is taking the standard deviation formulas from one sample up here and then already plugging them in and simplifying that down, right? When I do standard deviation squared, I square away this original square root. And that's why when you put it under the radical here in this formula, you only have the new square root. You don't have the square root for each of them. So I'm really plugging this formula in here, but when you square the square root, they cancel. So it looks like this, okay? Again, these formulas are on your formula sheet, so you don't have to memorize them. And then moving on, in this last one, Miss Caps and Miss George, it's a real battle between myself. Calculated a difference between proportions of 0.08 from their samples. Calculate the probability of getting this difference in proportions or higher purely by chance. Because it's approximately normal, we know we can use that normal distribution curve. We have 0.05 in the middle, and 0.08 is the probability that we want to know if it's likely, or the probability to get 0.08 or more. We're going to label 0.05, comma 0.0834. And then we're going to calculate our z-score. So z equals 0.08 value minus mean over standard deviation. And I get a z-score of 0.36, and then an area of 0.3594. Whether you use the calculator or the z-table, you do have to do 1 minus for the z-table to get that value. And there is our lesson for today. Let's go ahead and write our keepers. Hopefully they've loaded. Oh, there they are. Oh, and here's our keepers for today. Real quick, I just want to show you 7.3's keepers in case you did not get them in class yesterday. You can pause this, copy them down. For 7.4, differences in sample proportions. A sampling distribution of p hat 1 minus p hat 2. The shape is approximately normal if large count is satisfied. The center is that formula, mu sub p hat 1 minus p hat 2 equals p1 minus p2. And the standard deviation is the square root of p1 times 1 minus p1 over n1 plus p2 times 1 minus p2 over n2. And that's what you need to know for a sampling distribution of a difference of two proportions. I gave you a graphic organizer yesterday. You can start to fill these things in. We'll definitely do some filling in of it together on Monday when we're back. So see you then, guys. Enjoy your snow.